So that's why do 12C3 and do 12C9 and tell me what you get. There are actually quite a few of them. Not necessarily current friends, but you know what I mean? They're just kind of rude people. So what do you get? They're both the same, right? So what this is talking about is what we would call symmetry. So I want you to keep this in mind. Symmetry. As you write out a binomial expansion, those numbers get larger, even if whether you do the combinations or you do Pascal's triangle. Go back and look at Pascal's triangle. The number starts at 1, then it gets a little bigger. Somewhere in the middle, it reaches its maximum number, but then it comes back down to 1 in the same way. So all the numbers are always the same, going up or down. Is this what we're on now? Did I skip one?
Yes.
We're good?
Skip 2.
I skipped 2? Where's 2?
Or 3 and 4.
Spencer, skip it. Okay, x plus 3y to the 4th. Binomial. 2 things inside the parentheses. So what we're going to do is get in the habit of writing out everything. So we're going to put the first thing in parentheses, we're putting the second thing in parentheses. According to the rule, what we've been working on is we'll put the highest exponent on the first one and the lowest exponent on the second one. Can't get lower than 0. And I can't start any higher than 4 because that number right there is a 4. So that's the highest, 0 is the lowest. What's the missing number that's in front? And here's where you could do your NCR or Pascal's triangle. Let's just do NCR. So we're going to go 4C0. That right now represents our very first term. Remember I had you put the asterisk by those 2 rules. What that stuff said is these 2 numbers will match. The lower right number on your C here is 0. The top right number will match. These 2 things always match. The numbers on the outside, these 2 exponents, in this problem, always have to add up to 4. It doesn't. I just start with it. You guys can start in a different pattern, but now the next one will be 4C1. Then what's going to happen to your x and your 3y? The x comes down 1 number, and the y starts to move up 1 number. So what's next? 4C2. Your x does what? Comes down 1 number, your 3y goes up 1 number. 4C3. The x and the 3y, what happens? Down 1 number, up 1 number. And then, how do you know when you can stop? You know you can stop when your NCR, this combination that we're writing out front for the coefficient, when those 2 numbers are the same. So you're going to start at 4C0, 13C0, whatever it is, and when the numbers match, you know you're done. You're reaching the very end. So this will be x to the 0, and 3y, to the 4th, squish it in there. So if you, all the way through this problem, notice that 4 and 0, 3 and 1, 2 and 2, 1 and 3, 0 and 4 always add up to 4. So the exponents always add up to the original exponent. Yes?
Why do you do the C stuff if the C doesn't match the exponents?
Well, the C stuff, notice it's always a 4 in front, right?
Yeah.
But this number matches the top right. So this is a 1, that's a 1. This is a 2, that's a 2. This is a 3, that's a 3, that's a 4, that's a 4.
Why does the other one come down?
What's that?
Why does the other one come down?
Well, there we go. We're skipping ahead. We're simplifying. Pull the problem out of the oven. It's done for. Here's where, if you're not being a little bit careful, I get some different answers. The 3y squared when you're trying to do all these things mentally, I get a lot of students tell me 6y squared or 3y squared, they write down. But it is 3y times 3y, which is 9y squared. 4c3. Now, when we talk about the symmetry, we went up the hill. There are 5 terms, so we're at the maximum number when you're in the middle. Now it's the same coming back down, so it'll be the same as this 4x and 27y cubed. So 3y cubed is 3y, 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 so 27y cubed. And 4c4, 1, x to the 0, 1, 3y to the 4th, 81, y to the 4th. One times x to the 4th times 1 is simply x to the 4th. 4 times 1 times 3 is 12x cubed y. 6 times 9 times 1 would be 54 x squared y squared. 4 times 27, 108. And then 1 times 81 is just 81 y to the 4th. Now if you're sitting there going, wow, that seems like a lot of work, I think it would take you guys about 3 or 4 problems and that pattern becomes so much faster for you. Okay? It would not, and as you get better at this, I think you could do a lot of the steps mentally, but for this particular 9.5 section, I suggest you do what I did. The red represents me writing the coefficient, and then the 2 parts of the binomial to the correct power. The blue part is just simplifying anything that I can. You may be using Pascal's triangle to get the coefficient. You want to be careful in here as we start to do the different parts, squared and cubed, and if I have a negative sign. And then the green part represents final answer. So any questions on that pattern? That's the final answer. If you took x plus 3y times x plus 3y times x plus 3y times x plus 3y, that is what you get. Ready?
Somebody put the crack in it. Go.
So we're going to start out with a 5C0. Then you go 2x and negative y. So here with this negative sign, we want to be a little more careful. What powers are you going to put in on top of the 2x and the negative y? 5 and 0. Now notice I'm putting those 2 exponents on the outside of the parentheses. Because there may be times where we work with problems where the stuff inside the binomial also has exponents. And that can get a little bit confusing. So 5C0, 2x to the 5th, negative y to the 0. Ready? You start writing out the pattern. I'm just going to write it down. 2x goes down 1. Negative y is coming up 1. Then I'm on 5C2. You can use a vertical notation. Ooh, it's going to be really close on the end there. Start writing small. How many terms are we going to have when this is to the 5th power? 25. No. How many terms? Remember the 0 power has how many terms? Anything to the 0 power is going to be 1, so there's 1 term. So there's going to be 6. So I have the first 3 written out. Right? So we have 3 more to go. So this one, again, maybe I'll show you. You can just do 5C3 written that way to save space, you can use that vertical notation. You don't have to write c every time. You should know you're doing c's. The 2x comes down 1, and the negative y is going up 1. So those two outside exponents always add up to the original outside exponent. Then the next one is 5 and 4. 2x to the first, negative y to the fourth. And the last one, when you hit 5 and 5, you're done. 2x to the 0, negative y to the fifth. This is probably the maximum size that we would ask you to expand. After this, we start to ask questions about specific terms. 5c0 is a 1. 2x to the fifth is 32. X to the fifth. Negative y to the 0 is 1. 5c1 is 5. 32. 2 to the fifth. 2 times 2 times 2 times 2. Times 2 times 2. 2x to the fourth is 16. X to the fourth. Negative y to the first is negative y. So this is that negative sign I'm talking about. Watch your odd and even powers on the negative. What's 5c2? 2x cubed would be 8x cubed positive y squared. Now, keep in mind we went up. We're at the end of the beginning, right? So 1, 2, 3 terms. We have 3 more in the back. So 1, 5, 10 are the coefficients that we will use again. What's 5c3 would be 10 again, like we talked about. 2x squared is 4x squared. Negative y cubed is negative y cubed. 5c4 is 5. Oh, 5. 2x. Positive y to the fourth. And then 1, 1, negative y to the fifth. So that's kind of crazy.
What is this?
So in the beginning, I have 32x to the fifth. My second term, I would look at it like this. 5 times 16 times negative 1. So I do my numbers first. I get negative 80. X to the fourth and a y. The next term, 10 times 8 times 1 is 80 also, but this is a positive 80. X cubed y squared. 10 times 4 times negative 1 is negative 40. X squared y cubed. 5 times 2 is 10. X y to the fourth. And this last term is negative y to the fifth.